solving exponential equations. We'll start with an algebraic approach. Directions say solve each exponential equation. If the solutions are irrational, write them in exact form and also round to 3 decimal places. For the first example, 2 to the x minus 5 equals 8. Let's rewrite 8 as a power of 2. Now that we've done that, we're going to set our exponents equal, and we'll solve this simple equation, getting our solution of x equals 8. For the next example, when we have x up in the exponent, we can write this as a logarithm, as a logarithmic equation. Log base 2 of 10 equals x. So my idea here is to use the change of base formula, and we will rewrite x as log 10 over log 2. That's the exact answer. I can type this into a calculator and get an approximate answer of 3.322. For the last example, I can't, unfortunately, rewrite this using equal bases, and I have an x on both sides, so I can't just turn this into a single logarithmic equation right now. But what I can do is take the log or the natural log of both sides. And now that I've done that, I can apply properties of logarithms. First of all, that exponent of 1 minus 2x and the other exponent of x is going to come out in front. And I can see that I can apply the distributive property and get natural log of 3 minus 2x times natural log of 3 is equal to x times natural log of 4. Now, just like with regular algebra, when you have an x on both sides of the equation, you're going to want to rewrite it so that it's on one side of the equation. And I like to try to keep everything positive, so let's add the 2x ln 3 to both sides. Now that we've done that, we can factor out an x. And this is the goal, because now I can divide both sides of this equation by the expression that's in parentheses. And my exact answer is here. Another version of my exact answer looks like this, because I could apply the property of when there's a number in front of the log, it's the exponent of the term. My approximate solution, I can use a calculator, and it's approximately 0.307. So in examples 2 and 3 of this, notice we did need a calculator. So when the example is not, when the solution is not an integer value, you're going to need a calculator. Now we're going to go on to solving exponential equations by graphing. What we want to do here is, first of all, notice that there's an x on both sides of the equal sign. So we could graph f of x equals e to the x. I could graph that first. And then I could graph g of x equals negative x, which is going to be a linear function, right, that goes through the origin with a slope of -1. I could use a graphing utility to figure out where do these two curves intersect, and that is going to be my solution. We want the x value, which is approximately -0.57. The next example, we have an x on both sides. So we can graph the first function as h of x equals natural log of x. We can graph j of x as equal to x cubed minus 1. And we can see where do these two graphs intersect. Those are our solutions. We have two solutions in this case. X approximately is equal to 0.39 and 1.